Regulator is a device which helps us to regulate or maintain an action to a set or desired value. For example, if I want to maintain my car speed to say 60 kmph, then I need to constantly observe its speed and regulate the same. A voltage regulator constantly observes the output voltage and tries to regulate or maintain it to a desired or set value. I am Reshma, and today we will discuss about regulators. The main topics today will be what are regulators, need for regulators, types of regulators, line regulation, load regulation, advantages and disadvantages of regulators. A voltage regulator is a circuit consisting of electronic components that maintains a fixed voltage at its output terminals irrespective of changes to the input and load conditions. It consists of passive components such as resistors, inductors, and capacitors. The active components include diodes, Zener diodes, transistors, and MOSFETs. A voltage regulator is used in all our everyday applications. The need for voltage regulator arises for the following conditions. We need a voltage regulator whenever there is a mismatch between the supply voltage and load voltage requirement. If there are variations and fluctuations in supply voltage, then regulators remove these to give a steady voltage to load. If the load themselves vary, then it adjusts itself to maintain steady voltage at its output terminals. Let us assume we have a 9-volt battery and we want to run a 5-volt fan. The voltage of the battery is far higher compared to the rating of the fan. Therefore, we cannot directly connect the battery to the fan as it may damage it. We have to buck or step down the 9 volts from the battery to 5 volts before it can be applied to the fan. We need a 5-volt regulator that can buck or step down the 9-volt battery to 5 volts before it can be applied to the fan. As the battery discharges, its voltage will start falling. Even as this happens, the regulator must maintain constant voltage at its output. If the input voltage at its terminal falls below the rating of the regulator, then it may stop its operation or deliver a low voltage at its output terminals. Now, if we were to increase the load on the regulator, say by adding another fan, the regulator must maintain constant voltage at its output terminals. If the load connected is beyond the capability or rating, then it may shut down or reduce its output voltage. Regulators are broadly divided into linear regulators and switching regulators. Linear regulators are further divided into series and shunt regulators. They generally operate on the linear region of active elements. Switching regulators are further divided into buck regulator that steps down the input voltage, boost regulator that steps up the input voltage, inverting regulator inverts the input voltage, buck boost regulator steps up or down the input voltage, flyback regulator used to derive an isolated voltage, and C-peak regulators. The major difference between linear and switching regulators are as follows. The operating mode of a linear regulator is in the linear region, while the switching regulators operate in the saturation region. This means that the switch is either completely turned on or completely turned off in switching regulators. If the difference between the input and output voltage is high, then the loss is high in linear regulators. As a result of this, the efficiency is low. However, in switching regulators, if the difference between the input and output voltage is high, then the loss may not be high, so the efficiency is high. The output of a linear regulator has the same polarity as that of the input voltage. Switching regulators can be designed to have the same polarity as that of the input voltage, or it can be designed to have a reverse polarity in the output. In a linear regulator, the output voltage is always stepped down from a higher input voltage. But in switching regulators, the output voltage can be stepped down or stepped up from the given input voltage. As the linear regulators are operated in linear region, it has low noise and ripple at its output. However, in a switching regulator, we can expect switching noise. This can be reduced by using additional inductor filters. The control of a linear regulator is simple with passive devices, but in switching regulator, it requires complex PWM-based controllers. In linear regulators, electronic components are less, and the efficiency of the linear regulators is also less. As a result of this, thermal losses are high. This loss increases the temperature of electronic components. In order to reduce this temperature, we have to use a huge heat sink. Thus, the overall size of the linear regulator increases. In switching regulator, the electronic components are more compared to the linear regulators, but its efficiency is quite high. As a result of this, the thermal losses are less, and hence it does not require a big heatsink to reduce its temperature. In practical regulators, if the input voltage is varied, a change in output voltage is seen. To quantify this, a term is introduced which is called as line regulation. It is defined as the ratio of change in output voltage to the change in input voltage. For example, let us vary the input from 10 volt to 15 volt and the output is measured to vary from 5 volt to 4.9 volt. Then, line regulation is given as delta V out by delta V in, that is equal to 5 minus 4.9 volt divided by 15 volts minus 10 volts. This is equal to 0.02 or 2%. Line regulation is calculated as full load. In practical regulators, if the load is varied from no load to full load, a small change in output voltage is seen. To quantify this, a term is introduced which is load regulation. It is the measure of the ability of the power supply to maintain the output voltage for change in load at a given input voltage. It is defined as the ratio of difference of voltage at no load and voltage at full load to voltage at no load. Let us vary the load from no load to full load and the output is measured to vary from 5 volt to 4.8 volt. Then, load regulation is given as 5 volt minus 4.8 volt by 5 volt, which gives us 0.04 or 4%. In this video today, we learned about different types of regulators with their pros and cons. In our subsequent videos, we will look into these regulators in more detail. Until then, let's keep exploring and learning. Thank you.